So I'm Coburn Watson, and I started the SouthBay SRE meetup about a year ago, wanting to build a community in the SouthBay focused on reliability engineering practices, which is obviously a very large domain. I think we have about 740 people now attending. And what I'm looking to do, especially as an example in this presentation, is broaden the scope a little bit. Instead of just being maybe core SRE practices around, on-call, alerting, and so on, extending it into some various domains. So today's cloud capacity planning. We're looking to program one in the next month or two on cloud network engineering. And what I wanted to throw out there is this isn't really a Netflix meetup per se, even though we started it. We're looking for other companies who want to participate and host. And so just reach out to me if there's a topic you'd like to run at your campus, and we can use the meetup to grow that community. So cloud capacity planning. We're going to give 3 presentations tonight, ideally somewhere between 15 and 20 minutes each. There's a couple people up here. Andrew's the one with the motorcycle helmet on, but talking to you tonight. I'm going to talk a bit about cloud capacity planning and how it might differ from some traditional DC or on-prem planning. Andrew's going to talk about holiday planning and how we do it here at Netflix. And then the last one is the tools and the analytics behind the planning and how we leverage that by Sebastien, sitting over there. All right, so cloud capacity planning, for a lot of people that step into it, you think, well, why would I have to do capacity planning if I'm on the cloud, right? Fully elastic, just let people launch and it's taken care of, and there's no concerns. So I do believe it's a simplified model, but what I wanted to do was call that out tonight, what my understanding of it is based on my experience, and see if that resonates with you. Quick question, who here works on capacity planning part or full-time? All righty, cool. And who here at their business or company works with the cloud, deals with cloud deployments? Okay, excellent. Good, well hopefully it's of interest to you. So Netflix, I always give a little overview of who we are as a company. So we have about 83 million households that currently have Netflix, so that translates into some number of users. If you have teens, it's a lot more. We're in 190 countries, so earlier this year we launched globally and unlocked it for just about everywhere in the world. Our traffic at night is approaching, we're about 35% of US internet traffic at night. One thing I want to clarify is even though we're entirely on the cloud, the Amazon cloud, the content that you watch is not streamed off Amazon, right? We have a purpose-built CDN, that team's here on the campus as well, called Open Connect, and it's based on FreeBSD, and we give appliances away to people to basically stream very close to where they live. We give them away to ISPs, not to people, so sorry about that. Need to clarify that, I'll get in trouble. One of the things we do that's unique is at our scale, we actually evacuate one of our AWS regions once a month, and we run in that mode for 24 hours. So I think we might be unique in some respects in terms of how we do that, and we have a traffic management team that executes that. Capacity planning, and this is a little bit of a lead-in to how I think capacity planning is simplified, is that we only have 5 people in Netflix across 3 different teams that handle all of the capacity planning, given the scale we're at. So I think it's pretty impressive. I enjoy it as a part of my work, so I'm going to talk about that. These are the list of things that were sort of top of mind for me when I think about traditional capacity planning, particularly if you have a data center or you're doing on-prem, and maybe even hybrid and you're not fully yet embracing the cloud. So a lot of these concerns are ones that I don't have to deal with that much, but think about facilities, right? You have to work with planning, you have to deal with power, space, network. There's a lot of math that goes into it about make sure you can support the loads that are coming in. Supply chain management. You might say to Intel or someone, hey, to Intel, probably not likely going to happen, right? So you have these supply chain concerns and pre-ordering sort of windows you have to get into. Failure rates. People oftentimes wonder about when's a disk going to fail, you might actually have a buggy, firmware on your network card or something. And systems management staff, actually people to run the systems, be in the buildings, get paged and make sure nothing catches on fire in the middle of the night. The additional ones I consider higher order capacity planning problems, which is once you get the facilities and hardware dimensions of it out of the way, you really stand back and think about things such as how much capacity do I need in the light of many different dimensions? One is seasonality, non-periodic bursts. Maybe there's the World Cup and you're showing something related to the World Cup. We all have concerns around co-location. We want to make sure we don't land workloads together that can't play well together. Over provisioning, so I don't know if you guys deal with this much, but you want to make sure the site's up. You know, especially if you're a web scale company, if you run out of capacity, that's a bad thing. And you have to have load shedding strategies, tooling, and business continuity planning. So when I scroll forward and then you move into the cloud world, and it's not quite that great. It's pretty cool though. You eliminate a bunch of concerns. So if you think about our role as capacity planners at Netflix, those top concerns are, in our case, Amazon's problem, right? Like it's their job to make sure there's facilities, systems are ordered, and they have system management staff. And so it greatly reduces, I would say, the domain of things that I need to focus on a day-to-day basis. And that allows us to a large degree to run with the size staff we do around capacity planning. And we don't run intentionally thin. It's just that's how many people are really needed to address that space within Netflix. So they don't all go away. Now it's a really good story. Like, hey, go to the cloud, much easier, a few people run it. There are things that are actually distinct, I think, to the cloud capacity planning space, and these come into the picture when you move in that direction. This is the biggest one for me in general. You don't know where the capacity bounds are, right? If you have a data center today, you probably run a command, have some system or some report that says, hey, we're at 80% utilization of our capacity out there in DC, I-84, whatever it is for your company. It's a nice security blanket, right? Because you actually know where the boundaries are. So once you move to the cloud, you don't really know where those boundaries are. You might know where the boundaries of your guarantees are or certain resources, but I think of it as like walking in the dark really fast or a little bit slower and trying to feel where the wall is. So that's one of the things that comes in with cloud capacity planning. Vendor decisions is a pretty big component of that. So when you think about hardware evolution timeline, you have a bunch of business drivers, you have cycles, you have different rates of innovation. You might decide 5 years ago it's time to retire it. There's new generations coming out from Intel or whoever, and we're gonna rack up on that. When you move to the cloud, that's not necessarily in your control. You have the ability to determine when you get off old hardware to some degree, but you can't stay on it infinitely. And what happens is the systems start to fail over time and the performance profiles improve. It's actually in your best interest to move. And so you work pretty closely with the vendor to understand what those cycles are. One thing I consider a positive is if you land your own hardware and manage it, you spend a lot of time thinking about what the magic recipe is that gives you the right configuration for a system in terms of the combination of the processor, the memory, the disk, and so on. In our case, Amazon, they have teams of people who spend a lot of time putting thought into how very sort of heterogeneous workloads can perform well on certain systems and try to find a nice mix. The minor negative is sometimes you might say to yourself, I'd like a little bit more network on that type of system or a little bit more disk. And maybe you don't have that flexibility, but at the end of the day, you don't have to spend a lot of time losing sleep over that. The biggest positive, I think, for cloud capacity planning is being able to depend on demand, right? I really, for the most part, don't worry about running out of capacity. You know, if you look at our account, we run on demand all the time, not to a large degree, but our assumption is if we find what we've asked for or said we need to run with, I'm not going to be woken up at night because suddenly all the hardware's gone in the data center, and we consistently flex into that on-demand pool. Here's some details about the Netflix model. So any of these that you take, you need to tailor them, and this is, I would say our model's evolved over the period of a number of years and continues to evolve. As I pointed out, you depend on that on-demand pool. That's just a great luxury to have that, to avoid getting woken up at night. To the aspect of not knowing where your capacity bounds are, you know, you want to run as fast as possible, let engineers know, innovate quickly, don't worry about it, we've got you covered. And what that means is you have very effective telemetry about when you're not getting capacity. And on Amazon, they call these insufficient capacity exceptions. It's basically a message that comes back from an API. And it's I think of it as like a sonar. It's sort of something we're keeping a pulse on, and when it gets to a level that's of concern, we'll reach out to Amazon, very infrequent, but it also provides a great feedback loop if engineers are trying to get capacity and they can't, and we can actually give them some rationale behind why that's the case. I'll talk in a minute about 3-year reservations and what that means in our case. It sort of changes some of the expectations of the cloud. And we have these few large pools. So when you think about your traditional cloud vendor, and they show you this great long list of all the different types of servers and services they offer, particularly compute resources, maximize the size of your pool, it's good to align along certain dimensions for big families, right? So when you think about Amazon, they have high compute families, high memory, and general purpose. And so if you look at our distribution, we probably have maybe 15% in the biggest family, 20% in the biggest family, and it tails off very quickly. And that gives us a lot of flexibility, not only in terms of we basically manage our guarantees more effectively, but it gives us leverage in terms of making sure that when we optimize for a certain instance type, that benefit will be recognized by many other services. We have an analytics team. Sebastian's going to talk about that tonight, and I was going to point out Andrew's team helps with the capacity reservations. But to the point of you don't have all the utilities and instrumentation you do in your native data center. You need to build telemetry to give you that data as a constant feed, and we spend a lot of time thinking about where to extract that. Big benefit we leverage in Netflix, and I'm sure most people in cloud environments do this, is to some degree you want to partition your different services and different accounts for various reasons. Either they shouldn't clobber each other from a guarantee perspective, or it makes sense for, say, budgeting purposes to put them on different P&Ls. Within Amazon, when you set up your accounts, if you align them at the data center level, if I purchase capacity in one account and another account launches, they can get the borrowing benefit. And that ability to borrow financial benefit is, we had Andrew worked on a presentation on a blog post about our internal spot market. And so one of the roles of the capacity planning team is we have all this capacity we've paid for. We might not be using it. How do we find great candidates to go and use that? Part of that means we reach out to like the encoding team. And so when we encode our assets, I think in the month of May, they used like 3 million instance hours of unused capacity time to re-encode stuff that they basically didn't have to pay for, right? So we try to encourage development teams, like if there's something you really want to innovate on, and it can be it's an interruptible workload, there's a big pool out there you can go swim in. And it's a great opportunity for innovation, so recommend it. When you think about the way we apply the model, or how we came up with this strategy, we think about our capacity management in these primary dimensions at Netflix, and you guys probably do as well. You have the competing demands of innovation versus reliability and efficiency. And how you balance your focus on that within a company is typically tied to, let's say, your innovation goals, your efficiency goals, I think are the big drivers. I think we're all under the assumption that if your reliability sucks, you're not in business for long, so that one's always pretty big. When you move to the cloud, I believe there's some default directions these lean in. Innovation tends to accelerate rapidly, right? Because you unblock the long request deploy cycle that people have for hardware. Reliability, provision, your reliability improves. If you don't architect well for the cloud environment, your reliability can be worse. And efficiency, I believe by default of the rapid innovation, tends to be something that can drift off very quickly. And we had a cycle like that back in 2012. People deployed a bunch of stuff, we never cleaned it up, and then we went back and cleaned it up, it was like, whew. The preferred model is obviously you're moving in a positive direction on all these dimensions, and that ends up determining your distribution of focus. And so within Netflix, the cloud capacity planning team is in charge of making sure developers can innovate at the rate they want. We have the appropriate reliability, which I think is excellent. Netflix is almost always up. I own that function too, so I'm going to triple knock wood on that. And efficiency, the cloud capacity planning team at the end of the day is in charge of making sure that efficiency goals are achieved, and that's a whole other presentation by itself. So you'd like to think that it's all undifferentiated heavy lifting. Like if I'm a cloud customer, I can just step into the cloud and I'll get the same benefits of everybody else, and you don't have to really do a white glove service. Like, why don't I just accept everything as it is? We've come across a number of things which are what I think are important if you consider your scale and assume that in a case of like Amazon, where they have hundreds of thousands of customers, you might be a relatively big fish. And there's things cloud vendors do to protect themselves, probably like you do in your DC if you have a virtualized environment. You're not going to let someone say, give me all your capacity at once. Similar thing. So you might need guarantees. Amazon ran out of on-demand capacity. Would we want Netflix to stop working? Probably not. So what we do is we purchase capacity, guarantees or reservations to make sure that that capacity is there when we need it. We also do that for reliability. APIs have its limits in terms of understanding your environment. So we've actually had cases where we overwhelm cloud vendor APIs because we say, hey, every 5 seconds, why don't you tell me about 100,000 of these, right? And that's not really a normal use case. So we have built strategies to make sure that we can get the data we need around visibility without overwhelming the systems. And all resources have throttles and limits, right? And a lot of them are mostly logical. That's how Amazon and vendors tend to keep a handle on their environment. So if you need to have a load balancer or a certain amount of network bandwidth, that's probably a provisioned resource with a limit, and you might bump into it. So we've actually built a system called Howler Monkey. It ingests these alerts. When we hit a certain capacity limit, it automatically opens a ticket for Amazon and says, hey, could you raise our limit? Because usually cloud vendors don't want you to say, just set it to infinite for everything because I don't want to be bothered, right? Because that really scares them. And resource limits are set for lowest common denominator. So if you understand your cloud vendor and their customer landscape, most defaults are set for many sets of startups out there. A lot of us get free credits for something and we go and spin up the little app server. They're not going to let you launch 10, 15, 20, 30,000 instances in your account. And so we continually keep an eye on making sure that we understand. Internal spot, Andrew talked about that in his tech blog post. It's our job to make sure if we pay for capacity but we aren't using it because of auto-scaling, we find a way to creatively get people back onto that capacity. I put this in here almost as a joke, but if your billing file ends up being hundreds of millions of lines of rows of data each month, you have to ingest it into Hive and run analytics to break down your bill. So be prepared when you're really big to have lots of billing data. So in summary, you take the cloud, you add capacity planning, and I think in general, when you think about what it means for us, I wouldn't give it up for anything right now. And I hope that gives you a little bit of a perspective on the differences between the two, and I'm sure based on your experience, you have some other inputs. We're going to hold questions and answers till the end when all three of us can be up here, so we can make sure we can get through the presentations. But contact information, my team's Performance and Reliability Engineering have a YouTube channel with some videos we've done. And I own those spaces up there: reliability, performance, OS, traffic management, chaos, capacity planning, and cloud network engineering. So lots of stuff. It's like 25 people, so we scale pretty well. So that's it. So let me pass it off to Andrew, who's next.
All right. So I'm Andrew from the Cloud Capacity team. It's a cross-functional organization that we have, and I'm representing from the finance side. So when you think about Netflix and the holidays, what's some imagery that comes to mind? Kind of gathered with family and friends, watching Netflix, like watching Stranger Things, kind of find a way to plug that in there. When Reed talks about how we want to continue growing and becoming a quality service, he often cites winning moments of truth. So it's Christmas Eve, presents are under the tree. What we want you to do next is to watch Netflix. So you can imagine it's a very important time for us. What that means for the cloud capacity team, though, is a very stressful time, and I'll show you some reasons why. But before we move on, that's true. Finance people we just have money at our desks. It's real. I compared it to tightrope walking because we have to balance two things, and it's a very thin line. So as Coburn mentioned before, you can run out of capacity, so you can't run too lean, because the very last thing we want on that Christmas Eve is for us to have a capacity-related service outage. On the other hand, we also don't want to be too wasteful. Our primary business metric that we pace against is cost per stream, so the amount of dollars to serve. We purchase a lot for the holidays. Buying way too much for the holidays is a pretty terrible way to start 2017, so we also want to make sure that we purchase the exact right amount. So throw on some more complexities of the holiday season, very volatile customer traffic. You look at streaming peaks between days. It's almost double-digit differences. So we have to make sure we have enough capacity for each peak and then our super peak, which is in early January. Also need the option to do regional failover at any given moment. That's including at the peak during the holidays. So, holiday growth, holiday failover growth, how does that all translate into an actual forecast number? And there's no budgeting process, so we start our holiday forecasts actually right now, but we're trying to forecast a number in early January, just one single number of what that capacity is. service teams can change their architecture, their resource requirements can change. How do you get a handle on that and still accomplish that very first bullet point? So for a lot of folks, holiday season's pretty nice. For us, it's let's not get fired season. So before we actually talk about holiday capacity planning and some of the strategies that we have so it's not that stressful, take a step back and talk about the cloud capacity team in general. So our charter is to efficiently procure capacity so that engineers can focus on what they do best, which was innovation and availability. So Coburn mentioned undifferentiated heavy lifting. Yeah, so Coburn mentioned 1 or 2% of their time thinking about what capacity that they need, but that's not what you hired them for, and it's not what they're really good at. So we centralize that within this one organization, cross-functional, 5 people right now. We're likely going to grow to 7 by the end of the year, and we kind of help drive that general charter. So setting organizational context before we talk about the holiday planning. All right. So I mentioned the holiday planning starts right now, goes until early January. Important point is that you want to match your forecasting process, which is the beginning process, to what your environment looks like. So if you have 50 engineering teams and they all have equal usage, it doesn't make sense to do a bottoms up. At Netflix, we have a long tail, so top 10 services, top 10 engineering teams account for the vast majority of usage. So for them, we're highly aligned. We meet with them pretty frequently and do a bottoms up forecast for them. For the rest, we do it tops down. And we continuously iterate it to capture any changes that occur from now to January. Now, what's great is since we all do this in a centralized function, kind of like a control tower, we can make a lot of decisions around migrations or large landscape changes that we see over the upcoming months to help further efficiency. And we'll use a specific case study of one of our largest services, which we call API. So kind of a quick spec sheet on the service itself. It's about 1/5 of our footprint, auto scales heavily with customer traffic, runs in all regions. What it generally does is to a request coming in and serving that one request. And we're going to talk about it trying to move to a different instance type and all of the considerations we need to put in from the cloud capacity team. So the first thing is changing the trough, which is a fancy word for the unused reservations that we have. So I want to first talk about our general purchasing strategy. For very important services that sit on instance types, we try to purchase up to their maximum peak, including failover as well. So this would be our hypothetical reservation line for our 3 regions for API. One thing that's immediately noticeable is all that white space in between. And Coburn mentioned we wanted people to leverage trough borrowing, leverage unused instances. So what that means for the cloud capacity team is to first, talk to pre-compute, which mostly runs in our EU region, and let them know about what the new hardware type is and kind of whitelist them. Inside our US East one region, we talk to the encoding teams and make sure that they're also cool with the new instance type, and we time that migration together so we maintain the same level of efficiency, the same level of internal spot as before. Another consideration is managing failover capacity. So take another step back and talk about our general failover strategy. We try to serve customers where it's most performant from them from a latency perspective for different regions. You have to consider that people tend to stream in a pretty predictable, stream at night, less people stream at day. And knowing where kind of most of our subscribers are, you can imagine our regions are pretty unbalanced and there's a lot of variability throughout the day. So the most efficient way to manage failover capacity is to make sure that your normal usage capacity and your failover usage capacity for any one region equals the other region. So no one region is much larger than all the others. And that makes failover more efficient. So immediately for API, we have to figure out what all instance types in the other regions related to failover and make sure we flip them as well. And we also think about who actually gets the capacity, because right now we're all in this one account and someone else can go grab API's capacity. So kind of not a really elegant way we do it for API is that we sit them on one specific instance type and we kind of steer other people away from that instance type because we think it's a very critical service. And it kind of works pretty well in practice. So kind of recapping, showing the charter again that we're heavily focused on efficiency and we have kind of this watchtower organization. Specifically for the API migration, we, by understanding our landscape and seeing where they're going to, we can continue maximize trust borrowing by doing all that coordination. If the API was a standalone service just upgrading its own hardware, then we'd lose out a lot on efficiency. We also help availability a little bit by, kind of steering them landscape and safeguarding it, and also making sure that the failover capacity is still applicable. And this is just one of our large service teams that we engage with. So we kind of rinse and repeat for about 14 other teams to make sure that they're ready for the holiday season. So when it comes around, you guys can watch Kimmy Schmidt, and then we're the ones just worrying on the back end. All right, that's it.
Okay, cool.
Andrew? So just to see if you're still awake, I thought we'd start with a quiz. And Coburn already gave away part of the answer, but let's see if you paid attention. So who can tell me how many lines we have in our monthly detailed AWS bill? And I'll just help you along a little. Just shout one of the answers.
C.
C? I heard C. Any other guess? There's some B's. All right. 700 million. And while that's a big number, and part of my motivation here is to impress you with all the big numbers I have, there's actually something relevant behind this. So within this type of lines that we have to parse through every month, and I reassure you, we don't have someone actually look at them manually, there's a lot of complexity that we need to extract. So we have about 2,400 different applications that are running in this cloud ecosystem. All of those run on 80 different machine configurations, hardware configurations, which we call instance types. They run across 30 different zones. Those zones, think of them as data centers, essentially. And we have to manage them across 60 different accounts. So for those of you who are really quick at math, that's about 300 million combinations. And we have to make sure that all of those combinations are happy and well provisioned. Of course, it's not quite that complex. We don't actually care about all 2,400 applications equally. Some of them are bigger, as Andrew mentioned. So even if you reduce this to say like 100 applications, you still have 1 million combinations. And even if you reduce this to assuming that all of your applications are equal and you can treat them the same, you still have about 100,000 different combinations that you need to make sure are provisioned, monitored, and everyone's happy. So why am I telling you all of this? Well, the reason for those numbers is the reason why my side of capacity planning exists. And it's also the reason why we're currently the biggest side of capacity planning, which is the data manipulation, which we call capacity planning analytics. So how do we do it? Our goal is to try to help every aspect of the capacity planning operations. For that, we have 3 different, complementary rather, goals that we use to implement to help that main goal. So the first one is to provide context and transparency. And those might sound vague, but I'm going to give you examples, so just be patient. So context and transparency is very important. The other one is once you have that context and all that data, you need to be able to actually do something about it. So we try to focus that context into actionable insights. And finally, if some of those actionable insights actually don't require a human to be enforced, we can implement some automation. And that's where we tie back with our Coburn side of the capacity planning function. So, by the way, if by the end of this talk I haven't covered everything that we do and you still have questions, Rohan and Torio are also in the team. They're sitting here, and you can go and ask them questions. And if anything breaks, you can also blame them. So let's start with the first goal, which is providing context and transparency. And that seems easy because, as I just told you, we have a ton of data. But I would argue that this picture here is a form of context and transparency. It's a horrible form of context and transparency, but it's one nonetheless. So obviously, that's not what we give our capacity planners here. We actually try to build intuitive and interactive dashboards. So what does this look like? So this is one example that's tangential to capacity planning, but that's capacity related. So if you think about Netflix, when people are watching Netflix, there is thousands of different device types out there. Each device type might be running a different flavor of the Netflix user interface. And what that means is we see very different interaction patterns between those devices and our cloud services and our cloud, those 2,400 applications. And because of that, we want to monitor devices that might badly behave or find good performance and see how we can reproduce that. So what we did here is for each one of our main user interfaces, we look at the range of what we call chattiness. So it's really the number of requests per device with some normalization. But you can think of it about device chattiness, how chatty a given device is with our cloud services. And the first thing you can see when you come here is that there is actually a pretty wide range for each UI. But aside for a few exceptions, the Plus Kids and the Akira here, everyone is fairly consistent. So that's already a first insight without doing anything. The other thing you see is there's actually quite a bit of variability over time, over the last 2 months or so. And if you want to drill down into that a little bit, you can go and select any of those UIs. It will update the bottom panel for a timeline just for that UI. And then maybe you can identify who is the culprit for that big drop or that big increase we got there in July, that big title. And then you have a ton of filters on the side to drill and investigate even more. And so I would argue that this is good context. It has a ton of transparency, and at least you can come in and get some intuition about what's going on. It has one major limitation, though. And let's see if you've been paying attention. We have to do this at scale. Who can tell me how many applications we have running in our environment? C, yeah, good, you're paying attention. So we have 2,400 applications. Are we going to go to the application owners? There's probably not 2,400 of them, but the many application owners, and tell them to go look at the dashboard and try to see if there's an interesting interaction pattern that we should investigate? Or are we going to do it ourselves and go investigate 2,400 different applications manually by browsing this dashboard? I would argue that this is not the best use of our time. And this is where we get to our second point, which is focusing on actionable insights. It's great to have transparency. It's better if you can actually point in the right direction. So this is a different example, but I think it's a better one. So what we wanted to do is look at efficiency. So efficiency obviously impacts capacity, and we want to track it. We developed 3 different metrics. One we call efficiency score, right here, streams per dollar, and RPS per instance. And the bottom 2 are pretty self-explanatory. The efficiency score, you think about it of if you know which one of your resources is your limiting resource, which type of memory or network, then how much you utilize this on average is your efficiency score. And so what's interesting here is we have a dashboard that shows the efficiency score, the streams per dollar, and the RPS per instance for all the applications. And people can go in the dashboard and explore it. But what we'll do is every week, we'll go into that data and we'll check for any changes, whether it's a change in the metric itself, so it just jumps in the last 7 days compared to the normal variability that we see for that metric and for that application, or even in the trend. So if your application was slowly improving the efficiency and suddenly you have a big jump, it improves a lot faster or it improves a lot slower, we'll also mark that as something worth looking into. And once we've run all this is not manual, we have code doing that. Once we've run all this, we send an email to each application owner with a list of their application that had something interesting going on in the last week. And so you can see here, this is an example where the efficiency score went up for 2 of the applications and went down for another one of the application. So if you've done something to your application during that week and you expect something to have changed, all you have to do is look at that email, make sure the change is about within what you expected, close it, and move on with your day. No dashboard. If, however, it's something unexpected, that's where it becomes even more valuable, because now something has changed without you wanting it to change. So what you're going to do is you're going to click on any one of those cards and do it. Our beautiful, interactive, and intuitive dashboards, and you're going to be able to investigate and drill down, and you get all the information you'll need down the pipeline. So this is how we provide actionable insights. So this is all great, but there's how does this apply to actual capacity planning operations? This is capacity related again, but we have actual internal operation, like making sure the holidays are provisioned properly. How do we do that? So in order to implement, to solve that capacity planning function specifically, we have 3 core requirements. There's more, but those are the core ones. One is to be able to monitor and classify our current footprint so that Andrew can go take a snapshot and know that this is how much we have reserved for that application in that zone, for that instance type. and this is how much they've been using in the past 2 months, and make sure that everything is okay. The next thing is provide some level of forecasting for the future capacity needs based on current usage, based on expected events like migrations, holidays, Super Bowl, whatever else might happen. And that's also very critical to making it easier for Andrew to make the right decisions. And finally, the last one is helping him even a little further is trying to optimize what's the right balance between on-demand and reserved capacity so that we have still high reliability, but we limit a little the cost too. Where it becomes title. For us, this is Picsou. So Picsou is two things. First, it's Scrooge McDuck in French. I'm French, if you haven't noticed from the accent. And we thought it was appropriate, given that it's cost-related and sort of hoarding tool. And also, it's our answer to a comprehensive capacity analytics tool, so that most of the capacity planning functions can be served by that tool. What does this look like today? But has any of you heard of ICE before? Okay. So at this point, for those of you who know ICE, we've essentially reproduced what ICE was offering. And that is a beautiful, interactive, and intuitive dashboard that tells you what's your current footprint usage, what's your current reservation, and you can drill down by who owns what and what products are they using, and all sort of interesting dimensions. So that's where we're at right now. We just started building this a few months ago. Where we're going is, I would say, even more impactful. So where we're going with this is those last 2 points. So we've done the monitor and classify. So in the next 6 to 12 months, our team is going to be working on implementing capacity alerts and forecasts. So that Andrew doesn't have to go every day and look at the dashboard and figure out what he needs to do next. We can go ahead and tell him, hey, there's a lot more usage and not a lot of reservation in that space. Maybe you should look at it. Similarly, we can help him figure out how much he's going to need to buy for the holidays by just telling him this is what the growth looks like according to our best estimate. Once we have those forecasts and alerts, we can actually enhance them a little further by telling Andrew, well, you should pay attention to this, but also I think that if you do this action, so if you buy this much, then you should be fine. That should be enough. And then Andrew just has to validate this based on his own tribal knowledge, which he has a lot of, and sort of process the purchase. But arguably, as we build confidence in that type of alerting and system, we can bypass Andrew sometimes. And that's where we would rely on Coburn's capacity engineering function to enforce those recommendations. So place direct purchase orders to AWS through some sort of API, or at least automate the spreadsheet we send them. So this is where we're going, and this is a lot of our focus at the moment. We've already done a ton of work on enhancing the data, but now we actually need to make it more actionable. This is super interesting and super impactful, and we're always looking for talented people to help us make it happen or even give us new ideas. So if you have any, please share. Thank you.